All right, let's do 8.1 number 7. How does that work here? Now, this describes a rather dangerous scenario. Imagine that you are inside a container which is filled with ethanol. So here it is, it's full of ethanol. E-T-O-H, sometimes written that way. Sometimes C2H5OH. But no matter how you write it, it could be pretty dangerous because this is pure alcohol. And so the idea is that you're sitting in there, just kind of sitting on a scale. And the question is, what will the scale say your weight is? Yes, do not try this at home. It is extremely dangerous. You would probably be killed very quickly, but preserved for a very long time, because ethanol is a natural preservative. Now, you may ask, why did I choose ethanol? One of the reasons I chose ethanol is I could have done this with a tank of water, but some of you have a density that is greater than 1, which means you will sink and the scale will have a reading. But some of you have densities that are less than 1, which mean you will float, which means the whole thing wouldn't work. So I had to choose some fluid to put you in where I could pretty much guarantee you would sink. But, not a gas, something dense enough where it would have some meaningful effect on what the scale is. So that's what the book gave me, that's what I went with. So let's start out here. So when you're sitting here, there are two forces acting on your body. The first force is gravity. The force of gravity is pulling you down. Now, we all know how to calculate that, and if you don't, I'm a little disappointed. The other force is the upward force, the buoyant force of the alcohol acting on your body. That is the buoyant force. And when you combine these two forces, you end up with the net force. The gravity pulls you down, the buoyant force pushes you up, and your combined force is your net force. So, our formula for the net force is this. F-N-E-T, for net force, is equal to the force of gravity minus the force, the buoyant force, okay? So let's write out what they are. So the net force is equal to, force of gravity is your mass times little g, minus, now the buoyant force is determined by three things. The density of the fluid times the volume of your body. The more fluid you displace, the more buoyant force you're going to have, times little g again. So let us go through this. So in this case, the net force for me, my mass is 108.9, although I think I picked up a little mass over the holidays. Times, now earthlings, you all remember that 9.8 is gravity, minus this set here. Oh, by the way, everybody please remember my dear Aunt Sarah. Please excuse my dear Aunt Sarah. Sometimes people don't remember that you multiply and divide before you add and subtract. The density of alcohol. Now, here's the thing. If you look in your book, I think it says that the density of alcohol is 0.083. But if you actually if you use Google to find the density of alcohol, you're going to find out that the density is, it isn't 8.803, it's 789. And I believe that Google is actually right and your book is wrong. And that was a bit of a head scratcher. Now, it could be an error. They may have been thinking about isopropyl alcohol. Isopropyl alcohol, instead of having 2 carbons with an oxygen group, instead of being like this, this is ethyl alcohol, what they describe here, ethanol. This is actually, instead of this hydrogen, you'd have another carbon here with more hydrogen. That could be the case. That is a larger molecule and so slightly denser. It might not be the case. It could be that they're thinking of a mixture of alcohol and water. Very rarely do you find pure alcohol. Although if that is a mixture of alcohol and water, it is a very strong mixture of alcohol and water. That could be a possibility. What I actually think it is textbook makers are always copying each other, and they're very protective of their work. If you have a bunch of tables and somebody copies, how do you prove they're copying? Well, one way you can prove it is if you deliberately insert an error, then if somebody copies it, they will copy the error. They can't say that, oh, we got that information for ourselves. The fact that they copied your error, your deliberately inserted error, means that you can point at it and it's like, ha-ha, that proves you copied me, and then you can sue them. That could be the reason too. Who knows? Whatever the reason is, there's only about a 1% difference, so if you used one or the other, I'm not going to make it a big deal, because after all, the thing that's limiting our precision isn't that, it's our 9.8, which limits us to 2 sig figs. But I digress. Let me get back to work. Okay, so we're going to say that it's 789 kilograms per meter cubed. Okay, my volume came in at 0.109 meters cubed. Your volume, unless you're my size, is probably not that big. And then times, once again, all earthlings, 9.8. So let us get calculating. So I've already done the calculations. That's why they're written down. That's why I keep looking at the desk, is because I wrote it down. All right, so I multiply these together. I get 1,067.22. We're going to round that off, so don't worry too much there. Minus, multiply these all together, and I got 842.81. Again, we're going to round them, so you're going to get a lot of decimals. Leave a few more than you expect to keep in the end, but you don't have to go down for 10 digits. And if I subtract that, I get that the net force is equal to 224.4 newtons. Now, how to round this? I have 4 sig figs, 2 sig figs, 3 sig figs, 3 sig figs, 2 sig figs. The least in both groups, the least precise number is our force of gravity at 9.8. So I'm going to have to round this to 9.8. We don't have any situation where there's one that's... But yeah, we're going to end up having to round this to 2 sig figs. So my net force is equal to 2,200 newtons. That's what that scale would say. If you want to convert that, that's going to be about 45 pounds maybe. If you're wondering what the scale will say. Again, don't try this at home. It's extremely expensive and extremely dangerous. So, but that's what you would get. All right? So, thank you very much. Have a nice day.